Part 2 in the run chart series is about interpretation of run chart data. In this stage, we're going to learn how to interpret the data in a run chart. What you must remember is all improvement requires change. However, not all change is improvement. We need to decide when we can get really excited about the changes in our data. You need to work out how you can tell if a change has resulted in real or significant improvement. For your information, these are the references that have been used to inform this presentation, particularly the 3 books highlighted in the images. We're now going to learn about random compared to non-random variation. When you look at your data, just because you've got some data points going up or down by say 2, 3 or 4, it doesn't mean that you've got real or significant improvement. This is what we call random variation. So when you look at your data, how can you tell if a change has resulted in an improvement? So when have the PDSA cycle tests made a real difference? So here we have some PDSA cycles, and what we need to determine is, have they made a real difference? Is your data showing random or non-random variation is the question. So random variation is natural flip-flopping around the center line, and this is where it is important to have the center line through your run chart. In this example, the PDSAs have not made any real or significant difference. What we have is random variation in this chart. So when we look at the data in the entire chart, we can see at the start we've got random variation. Then we have some interesting non-random signals of change. We have here a shift, which is some data points below the center line or the median line, a shift of data above the median line, an outlier or an astronomical data point, which is also called, a trend going up, and a trend going down. So these are non-random signals of change. Just a point that different charts use different terminology when they're describing random or non-random variation. So in a run chart, we call it random or non-random variation. In a statistical process control chart, technically, that's when you use the terms common cause and special cause. So common cause is your random variation and special cause is your non-random variation in the statistical process control chart. In a run chart, there's 4 major rules that are used to determine if the data is just random or if there's real change, in other words, non-random. The first rule is a shift. The second rule is a trend. The third one is an astronomical data point or an outlier. And the fourth rule, which is quite a little bit more technical, is about too many or too few runs. So what is a shift? So a shift in the process or a shift in the data points is indicated by 6 or more consecutive data points, either all above or all below the center line. The values on the center line don't add to or break a shift. So the demonstration here, we've got a first data point, second, the third one's on the center line, so that's not counted, third, fourth, fifth, and sixth. So this indicates a shift. So a shift means a time to investigate. What's going on? This isn't random data. Something's happening, something's going on here. So did an intervention or a PDSA cause this shift? So it's a time to investigate. And also to think that if the desired direction of your data is up, then this is actually good news. But if the desired direction of your data is down and you have a shift above the center line, that's not great news. So a trend, what's a trend in your data? So a trend is indicated by 5 or more consecutive data points, all going up or all going down. And the median line or the center line is not important when we're deciding if we have a trend or not. Like values do not add or break a trend. So a demonstration here, we've got our first data point, second, third. The next one is actually the same as the third, so we don't count that, fourth and fifth. So this is a trend going down. And again, a trend means a time to investigate. It's not random data. Something interesting is happening here. Did an intervention or a PDSA cause this trend? So it's a time to investigate. And if you have a trend going down and that is the desired direction you want for your chart, your data, that's great news. But if you have a trend going up and you wanted your data going down, then that is obviously not good news and you need to investigate why. So an astronomical data point, it's a data point that is obviously and blatantly a different value. It's an outlier, in other words. It's very subjective and it can be either very high or very low data point in your chart. Just a reminder that your normal minimum and maximum values in a data set is not necessarily an astronomical data point unless it is an absolute outlier. It's an astronomical data point basically means a time to investigate. You need to understand why the data point is way off, and it could be a data keying error, or there could be some issue in the system that needs to be reviewed. This is a summary of the first 3 run chart rules. So a shift is 6 or more data points above or below the center line, an astronomical data point or an outlier, and a trend, which is 5 or more data points either going up or going down. And now it's over to you. We're going to do an exercise. So look at the chart below and circle the shifts, trends, astronomical data point, and where the random data is. And then think about what would you investigate further and how you would do it. So how did you go with the exercise? I'll reveal the answer. And at the start of the chart, we had some random variation. Then we had 2 shifts and an astronomical data point, that way off figure, and then 2 trends, a trend going up and a trend going down. So the shifts, the astronomical data point, and the trends, that's what you should investigate further. How you would do that, you would look at those patients that created that data and look to see what was happening at that time. We'll now look at the last run chart rule for non-random signal of change, which is regarding too many or too few runs on the run chart. We'll now do an explanation of the calculations to determine if there are too many runs, too few runs, or if you have the expected amount of runs in the data in your run chart. So the expected amount of runs is not a signal of non-random variation, whereas too many runs and too few runs are both signals of non-random variation and, in other words, time to investigate. So what is a run in a run chart? A run is 1 or more data points on the same side of the center line. The number of runs is used when interpreting the data using the too few or too many run chart rules. So too many runs. So what does too many runs mean in a run chart, and what should you look out for? Too many runs can be a sawtooth looking chart, and this is a flag and a time for investigation. It may be 2 processes that you're measuring. If so, you need to split the data into 2 separate run charts or 2 sections of the same run chart. In other words, stratify your data. So there's a calculation to determine when there are too many or too few runs. We'll now look at too few runs. What can too few runs mean, and what should you look for? Too few runs can provide a signal of improvement. If the data is heading in the desired direction, this is good news. However, you would probably have seen a shift or a trend in the data, which are both signals of non-random data, so you wouldn't need to do these complicated calculations. You also need to check to see that you don't have 2 systems of data collection. So too few runs might mean that you've got 2 different people collecting data with different operational definitions. Or if you have a chart that looks cyclical, like this one, this could also be a flag for further investigation. You may need to stratify the data or think about, do you have different people collecting data in different ways? We'll now do step number 1 in the calculation to determine if we have too few or too many runs. The example below is actually, we've got the expected amount of runs, but I'm going to show you how you do the calculation. So step 1 is to calculate the number of runs. So a run, as we said before, is a data point on the same side of the center line. And a run can be a cluster of data points or just one data point. So in this example, we need to count up how many runs we've got, and there's a total of 11 runs. Another way of counting the runs is how many times the line goes across the center line plus 1. This is actually a much easier way of calculating the number of runs. So in this case, we've got 10 data points crossing the center line, plus 1 is 11 runs. And the next step is to count the number of data points that do not fall on the median line. So we've got 30 patients here, 30 data points, but we've got some that are falling onto the center line, so we don't count those. So it's 30 minus 4 is 26. So how do we do the calculation in our run chart to see if there's too many or too few runs? So step number 1, we count the number of runs, which we've done. We found there were 11. Then we counted the total number of data points on the run chart that does not fall on the median line. There were 26 data points. Now we need to use the expected runs table to see if the number of runs fall between the lower and the upper limit expected for the number of data points. So if there's less than, there are too few runs, and if there's more than, there are too many runs. And these are non-random signals of change, so it's a time to investigate. And if the number of runs falls between the lower and upper limit, this is not a signal of non-random variation. In other words, you don't need to do any further investigation. So this is the expected runs table. We had 26 data points that weren't on the median line, and the lower limit was 9 and the upper limit is 19 runs. We had 11 runs, and 11 falls between 9 and 19. So because 11 runs is between the upper and lower limit, it's the expected number of runs. So in other words, there's no need to investigate because this is actually random variation. Now it's over to you again. We're going to do another exercise. So just look at this chart and work out how many runs are there, and secondly, how many data points are not on the median line. So you can pause this video and then look at the expected runs table, which is on the next slide, to see if there are too few or too many runs. So from the chart, you needed to work out how many runs there were and how many data points were not on the median line, and then use the expected runs table to see if there were too few or too many, or the expected number of runs. So pause the video and do your calculations. I'll now reveal the answer. So how many runs are there? There are 30 runs in this chart. And how many data points are not on the median line? Again, there's actually 30 data points not on the median line. Then we used the table to see if there were too few or too many runs, and we found that there were too many. What I'll do now is show you in the next slide how we calculated that there were too many. So when you use the expected runs table in this particular exercise, we go to the row where there are 30 data points not on the median line. We look at the lower limit and the upper limit. We had 30 runs in this particular chart, and that falls outside the upper limit. So 30 runs is not between the upper and low limit, it's above the upper limit, therefore it is too many runs. In other words, it's a non-random variation and a time to investigate. So we've discovered with this chart that there are too many runs. So we're looking at blood test turnaround times in minutes. So what exactly would you investigate and how? So what did you find in your discussion? Maybe you could consider this. So with the blood test turnaround times in minutes, possibly this was the evening shift, the data from the evening shift, and this may have been data from the 9 a.m. to 5 p.m. shift. So what you could do here is possibly use two different run charts to chart this data. Now over to you again to do another exercise. So look at this chart here. How many runs are there? How many data points are not on the median line? And then use the table to see if there are too few or too many runs. So the answer to the exercise is, how many runs are there? There's 2 runs in this run chart below. How many data points are not on the median line? There are 12. And then using the table to see if there are too few or too many runs, we found there are too few runs. And this is actually good news because the desired direction of this chart is down and the trend is down. So I'll now use the expected runs table and demonstrate how we came to that answer. We had 12 data points that didn't fall on the median line, so go to the row with 12. You look at the lower limit and the upper limit, they're 3 and 11. We had 2 runs, which does not fall between 3 and 11. It comes before the lower limit. So 2 runs is not between the upper and lower limit, so 2 is below the lower limit and is therefore too few runs in this particular chart. And that's a signal of non-random variation and a time to investigate. So the rules are based on probability and logic. So they're based on the probability of less than 5% chance of occurring just by chance or luck or by a fluke when there was no real change. And it's similar to a p-value of less than 0.05. So in other words, if you had a shift in your data, it only has a 5% chance that it occurred by luck or by fluke or by chance. You can be 95% confident it did not occur just by chance, or you could say that you could be 95% sure it occurred due to the changes or some kind of influences on the process. If you'd like to learn more, Refer to the Healthcare Data Guide, page 77 and 78. The rules are based on probability and logic. With random variation, the chance of a data point falling above or below the median line or the center line is 0.5 or 50% chance. This is similar to the chance of throwing a head or a tail on a coin flip. The first flip of a coin is 0.5 or a 50% chance of getting a head or tails. Two flips is 0.5 by 0.5, in other words, 0.25 probability of throwing two heads or two tails in a row. So the probability of 6 sequential points on the same side of the median is as follows. 1 is 0.5 through to 6 is 0.016. In a random system, any point is equally likely to fall above or below the median line. So the rules help us to see unlikely variation, in other words, non-random variation. And this is the same as a p-value of 0.05. We're now going to do an exercise. So if everyone can find a coin and would like you to toss it 6 times, how many of you got either 6 heads or 6 tails in a row? It's rare that you'll throw 6 heads or 6 tails in a row. In other words, there's a probability of 0.016. This is similar to a p-value of less than 0.05 in research, or a 5% level of significance. So the shift and a trend are based on the probability of less than 5% chance, or a p-value of less than 0.05, occurring just by chance when there was no real change. So in summary, the rules for the run chart are a shift, which is 6 or more data points above or below the center line, an astronomical data point, a trend, which is 5 or more data points up or down, too many runs or too few runs. This is the end of this section in the run chart education session. Please go to the next part of the run chart series to learn more and to complete the quiz at the end.